So hello everyone, this is Hiren. What we have discussed, actually we have started the new subject on software engineering. We have started the chapter number 1, that is the software and the software engineering. We have discussed about the certain points like what exactly the subject is about, why you need to learn the particular subject. Okay, software engineering, we have defined the certain terms, we have seen the some of the points. The points are like duals, the role of software questions haven't changed, a definition of the softwares, a difference between hardware and the software. Okay, so this is what we have seen in the previous video lecture, like the definition of the softwares. Then we have seen that like the dual the role of the softwares. Okay, then we also have discussed some of the questions that are repeatedly asked when you are like going to develop any software. The question like the how much time the software will going to take, and what will be the cost of the software, what could be the complexity of the softwares, and so on. Okay, so also we have seen the different definitions of the softwares that has been defined. Okay, so and also we have seen the difference between the hardware and the software. Just we have defined that the hardware is manufactured and while the software is being engineered. Okay, so this was the thing. We have seen the difference in the terms of the hardware failure count as well as software failure count. We have seen that the when the software will going to fail, and what are the rates of the failure. We have seen the hardware failure rate. Okay, so these are the points we have discussed in the previous video lectures. Okay, so in now today's lecture we will see the changing nature of the software. So what we are exactly talking about, we are talking about the different types of softwares. Okay, so when we generally define a term as a software, so software is a generalized term. The software can be categorized into the different terms. It can be categorized into different types of software. The types of softwares like system software, application software, engineering or scientific software, embedded software, web applications, artificial intelligence, ubiquitous, and there are so many. Okay, so let's go one by one to define the some of the types of software. Okay, so starting with the system software we can define as the set of programs or the set of softwares which can be used to serve other softwares. Okay, so what exactly it is? Let's take the example of a system software is an operating system. So what exactly is operating system? Like a Windows, Linux, and the Mac OS. So operating system ultimately is a software. So it is a system software through which you can create other softwares like Word, PowerPoint, and all that, right? So this is the system software. Other examples of the system softwares are like compiler, interpreter, editor, linker, loader, and all that. So these are nothing but the system software through which you can deliver the other software. You can develop the other softwares. Okay, when you are doing a Java program, you need a Java compiler. You are doing a C program, you need a C compiler. So these are nothing but the system softwares. Okay. Then we have the application software. Application software, the name itself suggests software designed for the specific application. Let's say if you want to make a document, you can define Word. You can create a software for like a Microsoft Word. If you want to create a spreadsheet, you can use the Excel. If you want to see the charts, you can also work on the Excel. If you want to read a PDF, you will use Adobe PDF. Right. So these are the application softwares are built up for the specific application. Also, the application software run on the top of the system software. Of course, this all the application software runs on the Windows. This is the operating system. Okay, and the other software type is the engineering or the scientific software. So what exactly engineering or the scientific software is? It is a one type of software, we can say the application software. Okay, but in that you can say that scientific software is a software, but it includes the different scientific formulas and algorithms and all that. Okay, then you have the embedded software. Okay, then we have the embedded software. The embedded software is, you can say that the software is written in the hardware, like the combination of the software and the hardware. You are seeing the software components on the LED board and all that that are like embedded programming you are doing, your Raspberry Pi programming, right? So these are the examples of this embedded software. Then you have the different product lines. So product line software different works on a different segment. Let's say the softwares on the inventory side, software on the text processing, softwares in the multimedias. Then you have the web applications. Okay, so now I would like to go into the detail on the web applications. So here we are talking about the web applications. So there will be the two terms, websites and the web applications. So when we are talking about the websites is nothing but or you can say it's a set of a collection of a line of code in the program, but it delivers a static content. Let's say if you are creating a website of your city like Ahmedabad or Surat or Junagadh, so it will create, you are creating a website for the, you are showing only information about your city, like places to visit and all that. While when we talk about the web applications, we are talking about a dynamic application, dynamic software like Facebook, Instagram. When you log into the Facebook, you can do the multiple things like requesting someone, you will get the response in your chat message and all that. Okay, so these are nothing but the web applications. It's a type of software. Then you have the artificial intelligence software. See, artificial intelligence is also a web application, but it includes the more detailed models like machine learning models, neural networks, and all that. So it's like that. Then you have the ubiquitous computing, like small and IoT devices, wireless devices. You can say that the ubiquitous programming. You can then have the net sourcing. You can have the open source operating systems, databases. See, we are talking about the open source. So there is a term is open source. It does not only mean it's free. Yes, it's of course a free, but free does not it means open source. Open source, let's say we are saying that this operating system is open source. That does mean you can have the access of the code. You can customize your operating system or any open source softwares you want. Okay, so this is the thing. Then we have the .com marketing applications, like you already sitting Flipkart.com, Amazon.com, and any of your e-commerce website you are getting it. So these are nothing but the types of softwares we have defined. The main software you can say is a system software, a heart you can say the operating system, Windows, Mac, Linux. In Linux you can have the different flavors like Ubuntu, Red Hat, CentOS. There are so many. Okay, then let's move towards the next slide. Then you will have the, okay, so next we have the next type of software, that is a legacy software. This is a legacy software. The term is legacy means this software is developed for the longer term. Like it is developed from the so many of times and still it is running. Like, okay, yes, the hardware might change, the configuration might change. The hardware, let's say they were using the dual core to Duo i3, i5. So hardware configuration, it might be running on the cloud, but the softwares have been developed previously. It is currently running nowadays also. So this is nothing but the type of legacy software, some business applications, some applications running on the marine and all that, like on the defense system. These are the type of software. They don't want to rewrite the logic again. They want to use the existing that legacy. They want to carry forward. Just they want to change the hardware configuration. So these are the softwares have been developed for the longer term. Longer means the very long term. So this is the nothing but the type of legacy software. So these are the some of the characteristic of the legacy softwares. Like they are the adaptive, perfective, and the corrective. Adaptive in the terms of it must be adapted to meet the needs of the new computing environment. So as I told you, as the time goes, the hardware configuration might, yes, of course it will change. So these are the softwares is developed in a way that in future if the hardware changes, there will not be it should not be affected in the terms of the software. Yes, the software should be adaptive to change the hardware configuration. Okay, then it is a perfective. like must be enhanced to implement a new business requirement. Okay, let's say your business needs are changing in future, but it should be implemented in that way, it should adapt that. Okay, then it is a corrective must be changed because of the errors found in the specification design. Yes, of course, when you are developing a software, you might fail, face the problems in the future, so it should be corrective. It should be the corrective software one. So this is the thing we have discussed about the softwares as of now, like the types of softwares and the legacy softwares. Then we have, then okay, so generally when we are going to working for any IT industry, or like when we are talking about the software, initially there were some of the myths available there about the softwares. So let's discuss about the previous myths. Like the one of the myth were, we already have a book that is full of standards and the procedure for the building a software, one that provide my people with everything they need to know. Okay, so it is like when you are like going to when you are running a IT company, or when you are starting up any your IT software startup, you are hiring your resources. It is not like that your resources will read any written software book or programming book, and following that book they will able to implement a successful software. No, it is not going to use. Yes, you have to read the process, but always said that practical and theory will always be that on the different stages. Yes, on the practical approach you have to adapt that approach. So we cannot completely say that after reading complete things you will implement the process correctly. Yes, experience does matter. Okay, then we have the different myths, like if we get behind, we can add more programmers and catch up. Okay, so this is the more detailed term. Let's say you got the requirement from the client. Okay, so you are saying that this project will take around 3 months of time, and it will take around six developers to work on. But initially what you are saying that I will hire only 4 developer. If it is required in future, I will hire more developers. So this is thing is not like that. What is the reason when, let's say you are hiring a one developer, but that particular one developer is working on the software for the 3 months. Now after the completion of the 3 months, let's say if you find that you will need a more developer, so if you are hiring a new developer, it's fine, the developer will work for you, but he or she has to go on for all the work that has been developed by that particular developer for last 3 months. So it will take a time. He have to adapt. He or she should be trained for that software that has been developed. Okay, are you getting my point? Yes or no? Okay, so this is the thing. Adding a more people afterwards will take a time. It will ultimately delay a project. So to train him, to increase the communication with him, so it will take a time. So rather when you are starting working on a project, rather you have to define how much resource you will need, how much persons, how much developers you will need, not how much, but how many developers you will need while you will developing the software. Okay, then the different methods, like if I decided to outsource the software project to third party, I just can relax and let them form and build it. Okay, so this is also the detailed term. Okay, let's say if you got the requirement from a client, okay, like let's say I want to build a particular software. So it is, see, everything is not a cup of tea. You just drink it and you are like relaxed. When you are going the requirement, it is not like that you will get the project, you will throw the project with any IT company, you will tell him, okay, you will develop the project for me, I will deliver to the client, and you are just relaxing that you will get the money. No, it is not simple at all. Earning a money, it is not simple at all. So in this case, you have to be in the loop. Like while communicating with the client, you have to take the daily follow-ups with the team, you are with the company you are developing the software. You have to update it, like what they have done today, what are the updates, what are the errors, what they have developed, are you happy with or not. On tomorrow it is like what they have developed after a month, you are not happy with them. So this will not going to help. Okay, after they have developed anything, after a month you are not happy with that, then you have to pay the money to them. So rather you have to have be with them in the constant loop. Every day you have to update it. Okay, so these are the some myths that we have. The different myth is like a general statement of objectives is sufficient to begin writing programs. Okay, we can fill the details later. Okay, so this is a main thing. When you are developing a software, you got the requirement from a client. To understand a requirement properly is a primary thing. To understand a requirement, to understand a requirement properly is an ideal thing. Okay, so you have to have understand the requirement. So let's say if the client have told you to develop a ERP system, so it is not like you have just started to develop ERP system. You have to identify each and every module, each and every complexities, each and every risk. You have to communicate clearly, and according to that, if you are working as a project manager, like the role of the project manager is to collect the requirement. The requirement is a detailed manner. Once the requirement is collected, then you have to properly deliver that requirement to a developer. Okay, so you are the medium. You have to get the proper requirement. You have to capture the proper requirements from the client, and you have to deliver the proper requirements to the developer. If there is a gap in between, so what the project client needs, you cannot deliver on that basis, then ultimately your project will not be accepted. Okay, and you will not get the payment. So this is the thing. Ambiguous statement of the objective spell disaster. Ultimately, ambiguity, confusion will always create a disaster. So rather than, if you have any confusion on the side of requirement on the client side, you should ask the client first. Okay. Then we have the project requirements continuously change, but the change can be easily accommodated because software is flexible. See, this is the biggest myth. We are saying that the software is flexible. It is, yes, it is a flexibility, but flexibility comes with the cost of a time and cost of a money. Okay, so it is not like that you have started to build the project on the initial requirement. Now in the later on you will change the requirement. Yes, when requirement will change, software will change, but it will take a more time and it will be invested a more money. Let's say if you have developed a small amount of project, a small change might affect the different modules of the software. A small change in the software might affect a different, yes, it will affect the different parts of the software. It might get the errors on the other side, on the other module. So it is better your requirement should be calculated, it should be captured properly initially before moving towards the software. It is not like that you are getting only few requirements and you will get the further requirements in later. No, it will be so much time confusing, it will be so much complex thing, and it will always be more expensive thing. Okay, so these are the general myths. This have to be dealt before developing the software. Okay, these are the different other things, like once we write the programs and get it to work, our job is done. 60, this is not the thing, man. Once you write the code, program and get it work, your job is done. It's not completely done. 60 to 80% of your all effort expended on software occurs after it is delivered. Okay, let me give you the example. When the first version of the Facebook was launched, when the first version was the WhatsApp was launched, they were not perfect. There were so many of errors, there were so many of bugs. After correcting their, once they have, and how they found the bug, after so many of users started to use it in the real life. Once they started, all these bugs have been resolved over the times. Now at certain amount of time, we can say that these are the stable and you are using. Even now, Facebook or WhatsApp, when launch any new feature with a new version, they might have some errors, and these errors come from the market, from the real-time users, and after they get this error from the users, they will correct it. Okay, so it is not like that once you develop a software, this is a complete 100% bug free software, man. Okay, then you will have, until I get the program running, I have no way of accessing its quality. See, a formal technical reviews of the requirement analysis documents, design documents, and source code. Okay, so let us come towards the point. Now I would like to discuss the software process life cycle orally. So software is not about writing a code. There is actually, I have discussed on the previous video. The first step of your software development is a requirement gathering. Requirement gathering from your client. The requirement should be properly gathered in the detailed manner, and it should be properly documented in a document. The document called as a software requirement specification. You will get into the later videos in the later chapters. So your first phase of the software development is requirement should be properly captured, and it should be properly stored into a document, that is a SRS document. Once you have prepared the SRS document, the next step is a designing. Designing in the terms of not HTML, CSS, designing in the terms of your paperwork. You will define a complete architecture on your paper. Like in the terms of, you will define which are the technology you will use. Let's say if you're using a Java, how many number of classes you will use, what will be the name of the class, what are the variables, what are the methods, how these classes are connected. So this is the work of the software architect, a person or software architect who have 10 plus years, 5 plus years of experience in the IT industry as a developer working. This is a work for him, so designing a software in the paperwork. Once all these things are done, then the work of a developer come into the picture to developing a software based on the requirement and the designing. See, everything goes into the process. See, everything goes into the process. Okay. So what we are saying that until I get the program running, this is not your quality of the code is good, means you are doing good. The quality of your requirement should be good. The quality of your document should be good. Quality of your designing should be good. If it is good, ultimately your code will going to, your architecture of your coding will going to be good ultimately. See, when we are going to the process, the first phase of process is delivered good. Ultimately, the start of the second will going to be good. If the end of the process is good, ultimately the start of the third will be good. This is the chain of the process. Okay. Then we have a different point that the only deliverable work product for the successful project is a working program. No. On the time, as I told you, software is not about only writing a code. Software is not only about writing a code. Software is about a requirement gathering, about a designing, about a documentation, about a coding, and after coding, it is about a proper testing, proper detailed testing by testers and stakeholders, and the maintenance. So this is the different software engineering process, is a combination of this whole process, from requirement gathering, from designing to coding to testing and the maintainability. So coming to the point, your software process we are defining will come into the next later lecture. Your software process can define a different stage. The phase number 1, your requirement gathering, you can say the feasibility study. Phase number 2 is your designing and the paperwork. The phase number 3 is your coding, we can say as the implementation. Phase number 4 is your testing. See, testing is done by the different detailed manner. You have a separate chapter, will go into that, but it's not a small team. It's a really important part of your software development process. And then you have your maintenance. Once your software is completed, tested, when you deploy into the client, maintenance should be there after for certain amount of time, 6 months, 1 month, even after the years. Some software requires a constant maintenance. Okay. Then you have software engineering. Then you have the last point, that the software engineering will make us create voluminous and the unnecessary documentation, and will invariably slow us down. Okay. See, as you all said, creating a more and more paper will decrease your energy. No, this is not like that. What should have been implemented, it should be documented properly for the further updation. Creating the quality, not documents. Quality reduces the rework and provides a software on time and within the budget. Let's say if you are creating your requirement, gathering a requirement from from your client and capturing properly in a document, it will be usable in the future. In the future, when you are creating a testing, you have creating in the document, it will be usable, used into the future. Okay. So these are the some. So these are the somewhat about the basic of the software. This was about the introduction of your software. This was the software myths. Okay, I hope you guys are enjoying the things. This is the theoretical subject, but I am trying my best to provide my 4+ years of development experience to this subject, so that you will not going to be bored while listening this lecture. Okay. So what we have discussed, a quick recap on that, from the starting about what is the software engineering. We have defined the dual role of the softwares. We have defined the different questions that has been asked while you are developing a software, when you are going to develop a software. Then we have defined the definition of the software. Okay. Then we have defined the difference between the software and difference between the hardware. We have defined the hardware and hardware failure curve. That the curve is called the path top curve, of course. Then we have defined the software failure curve. We have defined that when the change comes to software, it might lead to the failure, but again the failure can be recovered. Again the change will come, software might get into the failure. Okay. Then we have the changing nature of the software. We have seen the types of software: system softwares, application engineering, embedded, product line softwares, web applications, artificial intelligence, and all that. Then we have seen that the legacy software, the software have been developed for the longer amount of time. Hardware configuration might change, but software will not going to be changed. Okay. Then we have the reasons for, yes, it should be the legacy software should be the adaptive, perceptive, and the corrective. Okay. Then we have the next, that is the software myths. We have seen the different things, like developing a software, getting a requirement properly, and identifying the proper amount of resources. Then you have the project requirements continually changing, and all this thing we have defined. Okay. So at the last, this was about the basic of the software. So in the later videos, in the lecture chapters, we'll see the software development life cycles, how exactly the software development life cycle is, exactly what we have defined, different software developing models that is being used currently into the market. Okay. So I hope you all guys are clear. If you have any doubts, you can put into the comments. I will answer you into the comment. If possible, I will answer you into the next videos. Okay. So this was all about the chapter number 1. So in the next video, we'll cover up the software development life cycle. So thank you very much for watching the video. We'll meet on the next video. Thank you very much.